Hi, everybody. I'm Diane Lipscombe, and here to welcome you to today's Carney Conversations. It's going to be fun, and it's a real thrill for Chris and I to host this conversation about risk, failure, and success with our two guests, Nancy Zimmerman and Adam Korn. Just to give you an idea of who Nancy and Adam are. So Nancy is the Brown alum, a trustee of the university, and she's actually the founding chair of the President's Advisory Council for the Carney Institute for Brain Science. And so Chris and I have worked with both Nancy and Adam for a number of years, and hence the invite, because we've learned so much from them. But Nancy is the managing partner of Bracebridge Capital. Adam Korn is also a Brown grad, and he's also a member of the President's Advisory Council for the Carney Institute, and he's the Chief Information Officer at 6th Street Partners. So I'm just going to give a little bit of a deeper introduction to both of them, and then, Chris, I should also say. Chris Moore is also here, Associate Director for the Carney Institute, and he and I, if you've joined any of these meetings before, he and I have been hosting these conversations for over a year now, which has been incredibly informative and just great to just be able to have open discussion. So back to Nancy, the co-founder and managing partner of Bracebridge Capital, which is a leading Boston-based hedge fund with over 12 billion under management. Nancy began her career at O'Connor and Associates and managed the interest rate option group on a worldwide basis for Goldman Sachs before she founded Bracebridge. As I said, a graduate of Brown, and her degree, her AB, was in economics and the practice and production of art. I already mentioned that Nancy is a trustee of the Corporation of Brown University and our chair of our advisory council. But I did want to just also give you an insight into just what an incredible person Nancy is. And the way that she's able to bridge between managing all of the endowments, private investment funds at Bracebridge, but in addition, being incredibly well-versed and deeply knowledgeable in the area of kind of basic research and the importance of basic research to take on some of the big societal challenges of our time, including she's been a real, really helped in promoting and funding cutting edge research actually very recently on COVID-19. So we're going to get into some of the reasons why she chooses to do that, and where some of the parallels are and where there aren't parallels in terms of what we do and what she does in her real life day job and night jobs. Adam Korn is, as I mentioned, is a chief, well, I didn't say, he's the chief information officer at 6th Street, $47 billion investments. And previously, Adam was the global head of securities division engineering at Goldman Sachs. Adam joined Goldman Sachs in 2002, and then he was named a partner in 2010. And before that, he was co-founder and chief financial officer of software startup. And again, I think, why I'm just going through this is to give a sense of the great experience that they both had after graduating from Brown. But Adam is also incredibly keen and interested in the importance of basic research, again, to really think about finding new cures and treatments for diseases and disorders for which there are none right now, and has been an incredibly valuable partner on our advisory council. So that's to say, just to sum up, that both Nancy and Adam care deeply about research and excellence, and finding solutions to major healthcare challenges. And they are, I think, this incredible pair of enablers and mentors, and they're just both simply brilliant. And so we thought we would share some of their deep insights with you. So what I'm going to do is to just kick off and have them introduce themselves briefly. I'll start with Nancy. But Nancy, we'd just love to know a little bit more about why you're interested in brain science. I gave a background to what you do during days and nights, but I don't know how you have time. But you've just been such an incredible advocate for brain science and the importance of it, but why? Like, what's motivating you?
It's a really funny question, which I really feel like the reverse is true. Like, how could you not be interested in brain science? I think it's really important for us to understand, like, what is a system and what is, shapeable, what's given, and obviously there are huge societal challenges of this moment, including neurodegeneration, which none of us who are attached to people will manage to get through the next couple decades without having some people we're attached to compromised by neurodegeneration. Even if we find the process to be a journey rather than some tragedy, it's still something that is a puzzle. And if you can stay curious and think about what we're learning all around, both from watching carefully and disease, we learn a lot about the brain, we learn about, and it's also a way to really improve the quality of life for a lot of people, and to make the world a better place in its most basic form. I feel like there's also a lot of learning to do here, which is just really exciting, and nothing captures one's imagination like some of the work that you guys are doing at the Carney. And so I think on any number of lab crawls or meeting a scientist or seeing people's work, the level of engagement and the super charged power that true interdisciplinary work brings, and the idea that we find solutions by talking to the people in the lab next door, even though they do something slightly different, is really inspirational. And, I really do find, you, Diane, inspirational as a leader. And when I think about how exciting it is that you're just like willing to just enter into any project or convince some junior person to enter into a project because you're an expert on something that's a settled matter in a field where that information is necessary to make the next step on a challenge, is really important. And this kind of collaborative, unblocking people, it really speaks to like everything that I found really interesting in my real life. And I guess I haven't really learned to make particularly nuanced distinctions between my day job and my night job. But, I think it's all exciting and immersive. And I really can't tell you what a great pleasure and privilege I feel like it's been to be part of this journey and in everyone's labs and hearing about their amazing ideas.
Thanks, Diane and Chris, for having me. It's really a pleasure to be here. Very excited about it. I guess I'm less intellectually curious than Nancy. She gave a very eloquent answer, and she just was drawn to this out of pure interest. For me, it was much more personal. My wife, who's also a Brown grad, class of '97, she was diagnosed a few years after we graduated with some rare brain disorders. And I remember, we were visiting all these doctors and neurosurgeons, and they were explaining to me the condition. And I realized I had no idea what they were talking about. And I should, and you're sort of playing God in this, process where you're having to pick which neurosurgeon should operate, and without a lot of information, it was a very frustrating process. So it was too late for med school at that point. But I decided I was going to try to get up to speed on my own. And so I started researching and reading. And I just got really fascinated by the area. And, I think the question is, why brain science at Brown? It was actually my development officer, David Keefe, who reached out to me, and I didn't even know about the Carney at Brown. It was something that, just because I was trying to align a way to get involved in a meaningful way with Brown, with interests, that I even understand that, this fantastic place existed at my alma mater. And so, that was many years ago when the Carney was not even called the Carney. But I would say that, all of the meetings and discussions and research I don't quite have my degree, but I've certainly, there are pockets of areas that I've gotten deeply involved and invested in, and it's just been a pleasure to be part of the dialogue. I feel like where I'm able to contribute is primarily because I bring a different background and skill set to the conversation. So there are a lot of people that I know have a much deeper background in brain science than I do, and a number of them are on this call. So I'm not going to tell them about the next area in brain science that we should not necessarily pursue. But what I can do with my background in engineering is at least offer some ideas around the best way to do that. There are enough parallels between what I've done in my career on Wall Street and dealing with really complex problems with lots of data that require a platform to build out infrastructure. Those are problems I've seen before, and yet when I speak to to Diane and Chris and Nancy, a lot of the problems that we're looking to solve at Carney seem to, they at least rhyme with a number of the problems that I've seen before. And so I feel like it's just been a great collaboration, and that's what's gotten me involved and excited to be part of this whole initiative.
Thanks for sharing your personal entry into brain science. I think we all, no one is spared, right? I mean, there's so many major challenges right now, and it's amazing how you both just dig in. I mean, you have a very, very active participation of like, let's just figure out how we move through this and get something done. And I just love that. I wanted to ask, I'm just going to jump in and start to really, we were thinking about risk and how much risk you take and success. And in basic research, there is this very long arc from conception to getting some funding. The normal NIH route for funding, you apply for a grant, you're not going to know for 9 months whether you are going to be successful, and then it might take another 3 months. And if there's if the government shuts down, then you may not actually get your grant for another 6 months. Right? So there's this incredible long arc. And then in basic research, certainly, so you have to have kind of a lot of faith in the process to feel that there's going to be some outcome, some measurable outcome that's going to have an impact. And I just love to kind of go back to Nancy and then back to Adam again. Have you tell us how you think about that? That process. Why are you willing to take these kinds of risks and knowing that maybe something that we're doing, collectively may not have an obvious impact for like 10 years. So what goes into the way that you think about that? I mean, I know how we think about that because we're just like embedded in the whole process, but how do you think about the balancing, the risk, the need, and then have this certainty around there's going to be impact, right? This is going to be important.
Thanks so much. That's a really thoughtful question, Diane. And I'm of course very thankful to be part of this dialogue. And I do think that all of our answers are from this conversation, which is why it's so exciting to be in a dialogue. And so I do want to hear how you think about it as well. But I think when I think about it, as a philanthropist, I obviously think this is the easiest of all possible things, because we either get somewhere or we prove that that's not a viable route. The consolation prize in science is also knowledge. Like every time we do careful science, we learn. So I think as a philanthropist, it's a really easy call because you know that you're going to have impact, even if it's not successful. So I think that the thing, once I came to being interested in giving money to science and then became part of thinking about how to get people to use their human capital in their labs to create science and to empower people to do science, we started thinking about this innovation grants, where we wanted to think about how can we make it so we have these risk dollars that de-risk things, so then if they are viable and we have proven concept, they can take the proof of concept and they can ramp and they can go into the process that Diane has so eloquently described, that goes on outside of Brown and over which we have little or no control, besides to create, and I think it is important, a lot of support for our scientists who are in that process, so that process doesn't become their raison d'etre instead of science, right? So like, you don't become a scientist to do all this stuff. So we got to really make sure that we take some of the things that I think Adam and I have seen in business and use those things to support scientists so that they're still doing what they want all day, which is science. Because once we ask them to do other things, then the world's really competitive, and people as smart as the people in our labs can figure out all kinds of things to do, if they're going to decide to spend some big portion of their time battling the system. So I think it is important to really think about the stuff that I don't really know I'll never know as much about science as anyone on this, on the Zoom, but I think it's important to think about what are the structures in place, what are the support, and what's the production function for getting from a novel idea to ruling it out as a possibility, or in some very exciting moments, figuring out that's really viable. So we started this innovation grant process, which I know everyone else is extremely excited that every single person we've given an innovation grant has gotten follow-on funding. But of course, that means that we haven't given out nearly enough innovation grants and that we haven't really gone out the risk. We don't have enough funds to get out the risk curve. So what did that tell us? That we basically still have a lot of things that are sure things or very highly likely and not very risky that aren't being funded. So if we take any kind of portfolio approach, we got to get enough funds so that the things that are quite likely, or in a very diversified way, to make sure that those things get funded. And of course, we want to get to these asymmetric risky things also by giving risk dollars, but we won't. The results that we have so far are either that we are in the most remarkable fertile moment in the most remarkable place in the history of humankind until now, or we still aren't funding all of the very clearly viable ideas that ought to get funded and will bring enough to the table. And I think that that's an important conversation for us to be having about how can we get to that place, and then what happens once we're over that speed bump. I know, Diane, that you have a little bit more information about kind of the rolling process of the innovation grants, which started in 2016.
Yeah, around there. Yeah.
And maybe that doesn't give a little context for people who are joining the webinar.
Yeah, they were the return on kind of those initial investments.
How much money have we given out? How much of money has Carney given out in the innovation grants?
Oh, John is going to probably be able to give me the accurate number. It's probably around probably around $4 million over the last few years.
Right, and we've gotten about.
Well, if you count the number of grants that people get post that and other things, it's probably about a 20-fold return on that investment, which is pretty extraordinary. What Nancy's raising, which Chris and I were, we reported back on this, and you and Adam, I think, just dove into this and said, you're not doing enough. And we were really excited about the success. And just what you said, we're not even getting to perhaps not even getting to the highly innovative research, because we're kind of still in that safe zone. But I want to push
back on that. I think we are getting to the most innovative research, and it's imperative that it be funded. I think what we're not getting to is the non-intuitive research, or the research that's beyond. That's a great idea. I wish it was mine. We ought to have the resources to fund that. And so I think that our first thing is to block and tackle and to find the resources to fund all that stuff. And then to make sure that those labs know that if they have good projects, and all labs know that if they have good projects, that there's a place to come, and that it doesn't have to sound like something we've all done before. And so I think that's important. And then I think we do have to think, and I think Adam might be able to speak to this better than almost anybody, about what's the right way to score it. Are we really supposed to look at dollars and returns, or are we supposed to look at successes? Because obviously the amount of funding that you get is a function of how much the world cares about the problem, as much as how good your innovation was, just like, and so the question is, how do we meter that? And is it important to keep doing postmortem, or are we supposed to be just really forward looking as we create a really diversified portfolio of novel ideas?
There's probably a balance, I think, between that, those two areas. Like, if I think about, and I totally agree, Nancy, with everything you just said. Like, having the sponsorship, the financing to pursue 10-year projects is absolutely essential, and you've been really at the forefront of that. The way I think about the answer, to this question is, how do you keep your focus for 10 years? Like, that's a big challenge. And I feel like it's if I compare brain science with being in finance, we have to, even in finance, you have to keep your focus for 10 years. The trick is not telling anyone that you have a 10-year focus. Whereas I think it's much more acceptable in academia to say that you're focused on a problem for 10 years. So just purely out of survival in finance, you have to break the problem down. You have to break it down into small chunks. And I think of it like a backward induction problem. Like, what your end state ought to be, and you just really need to go back and say, okay, well, what am I going to be doing in 9 years from today, 8 years from today? And you finally get to what it is you should be doing today. And you should be pretty clear about what the next year looks like. And back to Nancy's point, what are the measures of success? Like, how can I demonstrate that that was a productive year? And of course, with any research, you don't exactly know where it's going to go and what kind of results you're going to get. And, you may end up realizing you're headed down the wrong path. But that is all part of the research process. And you should incorporate that into the way you metric. And, I think that, from the perspective of people who finance and fund, any sort of scientific exploration, that feedback, hearing from the team that's doing the work, and knowing specifically, what their measures are, what they've achieved, what they haven't achieved, where they're hitting roadblocks. As an investor, that's really that's the conversation you want to have. Because then, again, as I said at the very beginning, I'm not the brilliant scientist that, you, Diane, or Chris is, but I think I can help you on the risk management side a little bit. Like, if there are specific obstacles, I can at least help you think through those obstacles. So I think the way to keep committed to a long-term project is to really break it down and be very concrete. And then what you realize, just like, when you run a marathon, the first mile becomes the second mile, becomes the third mile, and then finally you're, at some point you're done. So, but as Chris has talked about, and I'll actually ask him a question. He mentions the valley of death, which I know is pervasive in research. How do you manage that problem, Chris?
We're not going to get past that backward deduction thing you said before. That's the armor that it's such an important thing for scientists. Anyone who has to do something hard that requires creativity and risk and failure, to have that view. Like, what do you want to be? If this was your retirement party and you said, "Here's what I discovered," like, just have a fantasy. Okay, like let's if you're going to be in a business like ours where the rewards sometimes aren't as clear, work backwards. What do you have to do now? Where are your roadmaps for that? Who are the people that got there? What did they do? What were the seemingly? I think it's a really great. This is, along with many of the great things, answers. This is an example of the kind of stuff that we benefit from. And talking to you guys, it's a really good way to think. And then you work backwards. You say, okay, well, then I better bet on a risky idea now because they do take 10 years. But not, it doesn't mean only on a risky idea. Like, you know, but then that means I have to have at least 3 people I work with. Yeah, I can't just, you know, then there are entailments in terms of your operation, what you do with methodology, how you make choices around that. I think it's a really, really productive way to think in science, is to think about where you want to be if the fantasy worked out, and the class of kind of thing you'd like to be able to do. So in the Valley of Death concept, I mean, this is something that there's 2 different valleys of death. There's 3 valleys of death. There is actually the Lonesome Valley we all have to walk, which maybe relates to other things, but we won't go there. Then there's at least 2 valleys of death. One is one that's often talked about, which is people in academia will have some idea that could have an impact on the real world. But the incentive structures of our lives, this is something we were really lucky to recruit Dr. Frederica Petschner recently to do our Brainstorms program, and she talks really eloquently about this. The incentives in academia don't align to then sitting on that discovery, let's say you discover a new thing that would help people with brain training or a new drug, or it could become a new drug if it got ever played out. It's really hard to get from the invention of it at the conceptual, like, oh yeah, that could be cool level. I've mapped out in a fantasy how it could be cool, to anything implementational, because the rewards that interim implementational period are really scarce. Of course, when you have a great new drug, everyone's happy you did it. And of course, when you have a great idea, you can get rewards in academia. But the Valley of Death is a path between those two. You know, it's small funding, it's indirect funding. It's a lot of work that you're often not praised for because it's just testing, not necessarily creative or innovative ideas. It's really just testing the product per se, and doing a lot of the hard work that we aren't often rewarded for. So there's a real incentives problem that people get trapped in. That's true with a couple of different ways of that. You're right. The Valley of Death, unfortunately, keeps a moat around the ivory tower that is hard to get over.
There is another danger there as well, which is that there is another route, which would be, you don't chase the invention and this great idea that you have, but you say, well, okay, like I need to get funded, and so I'm going to change my goal. And so my goal will be, I'm going to get that NIH grant. And in order to do that, you get completely, diverted. And so like that's also the added risk, I think, in the way in which our incentive structure is basically, as has been established. I mean, and so that I also wanted to just add, I think it's hard to get through that, but then there's also these off-roads that, you're just so incentivized to take, which in the end is not taking you to that, to that kind of blue sky type of trying to address the question. So I think, that the early funding becomes beyond essential, and there's no other way of even getting on the road.
Can I ask a question to Nancy and Adam? So I really, there's the lyric, there's no success like failure, right, in the song. But unfortunately, the word failure means failure. It actually means what it says. And this is something we've talked a lot with John Davenport about, and he's had some really neat insights into this. But in your own organizations and your own, going from knowledge to risk-taking, how do you incentivize people to be willing to do things that might fail? How do you get that hummus right around failure? Because a lot of pretty good hits is often a better career strategy for us than a couple of glorious failures. In fact, people are almost made fun of sometimes for being the kind of scientist who has those crazy ideas and this, How do you manage that in your own organizations? Like, how do you get people to take the risks that might, maybe it'll be a big hit, but you also might, I guess, lose money would be or lose time, lose energy, human capital. How do you incentivize that? Because that's something we have to think really deeply about.
It doesn't speak exactly to like it doesn't really It rhymes in some very, very vague way, but maybe a little bit more as a sort of spoken verse thing. But I think here's how I'm thinking about this, and I'll try to tie it back to why I'm pretty sure that that's an okay way to think about it, that you're not going to get yourself in more trouble than not thinking about it at all. We do have to think about these problems, right? The world exists as it exists. It's a competitive place. We, even in our innovation grants, think it's a success if someone gets NIH funding. So it must be that we have some idea, if you could prove this, the NIH would fund it. And it may not be that the NIH funding it is going to actually get you radical transformative science. So, we need to wrestle with those things, but nevertheless, the world exists as it is, and we've got to build a portfolio, right? So we have some things that are R&D, where we're doing something with some part of our time, where we think we'll learn something, we'll have cultivated a relationship with somebody who can teach us something, or we could learn something ourselves. We have grappled with what it looks like to undertake a challenging problem, which we may at the end have the humility to say we cannot solve. And those things are all really enriching, and they're not calling, like, deciding to dig elsewhere is not in any way, and certainly not in science, anything that anybody ought to be classifying as failure. And whatever systems we have created that have made that so, we should be thinking on a much different webinar, a very deep way, how we're going to change that, because that's not going to serve us, right? Knowledge. So, and that's the difference between the university and a big pharma. It's the difference between the university and Bracebridge, right? Is that this is the business of the university, which is to explore things, but not be ridiculous, and explore them beyond the fact that they're not worth exploring anymore. And we need to get some alignment with professors and with investigators around taking a modicum of career risk without having them go off the other side, where people are doing things that you, Chris, might actually think are not realistic, because there's so many intermediate steps that you need before that could happen, right? That the world, we've got to first turn the earth before we can plant any seeds. So I think we have to think about these things. And when, one of the great privileges of watching Diane in action is seeing her sort of help people manage their human capital, seeing her help people de-risk collaboration so that they understand that you get something out of collaboration, even if we don't wind up getting the grant or want to publish a paper, that we learned a lot and we came out of it better than we went in. And that's part of what makes a community that's going to, over time, if they keep doing it, make real progress. But simulating progress isn't very useful. So I think we have a way of figuring out whether people are making progress. It's just probably too reductionist in our world, Adam, but I do think that you got to figure out how you're taking stock.
If I were to relate this back to maybe the world of finance for a second, this is sort of the role of the portfolio manager, which is really to select the right mix of projects or investments. And ultimately, this will create an efficient frontier. And then you have to figure out where on the efficient frontier, as a portfolio manager, you want to be. Obviously, I don't think it makes sense for academia to be as rigorous as that about how it invests. I think it's more of the business of in finance. But to your question about kind of incentives, I think back to the fact that my father worked at Bell Labs for many, many decades, and he had this very strange job, because he would from my perspective, he wasn't really doing much. He would go into work and he would think, and then he would come home and he didn't have to teach. He didn't have to write papers. Well, occasionally he did, of course. But when I was old enough, I finally said, why does Bell Labs do this? I don't get it. I don't see how this works out. Of course, he was like, well, you're destined for Wall Street. But the answer actually made sense. It was really this whole notion of Bell Labs, obviously, given the position they were in, they were effectively a monopoly before Bell Labs broken up. But really, it was such a big company that the ability to have one project succeed out of 100 could pay for the 99 failures. Like that was the math that the management at Bell Labs did. And when you have I don't know whether it was really 100 good ideas or it was 50 good ideas, but some number of those ideas definitely resulted in saving Bell Labs money. And it would really carry the research year to year. And so that's the power of portfolio diversification. And that, as it's really the only free lunch. So you have all these different projects going on, and as I'm sure Diane's thinking broadly about everything that's going on at the Carney. And at the end of the day, that it's totally fine to have those failures as long as you have some success that's going to ultimately fund those failures, because those failures are necessary to have those successes.
I mean, one thing to chime in there is Bell Labs also, not just on Marvelous Maisel, but in real life, attracted just the most brilliant people because they wanted to work there, right? Because failure was okay. Like that kind of failure, like I'm gonna go for it failure was okay. You also had to have the hits and all the stuff, but that was a very attractive work environment.
Yeah, actually it reminds me a lot of the Carney, because the thing that really kept my father there for so long was the collaborations that he was able to pursue. And he would work with people in completely different areas, and the only agenda they had was to help each other. And that's the environment that I think that you guys have created for the scientists in the Carney, and I think it's unique. It's really hard to create that kind of environment. And I think curious on Nancy's perspective, but I think that's a challenging environment to create, certainly in finance.
One of the things that's been enormously rewarding about being involved with Carney is watching the collaboration and thinking a little bit about how to make something that's collaborative. I feel like COVID was amazing for watching people out of the best parts of themselves decide to collaborate. Maybe it was to get out of their house or to get their kids back at school. I know I certainly was interested in that. But I think we did see a lot of exciting collaboration, which reminds us all the time that people are really complicated. And that's also at the heart of brain science too, right? Like what really makes us tick. And people want, if what makes you tick is figuring stuff out, going to work all day with other people want to do that and kicking it around like your dad did, or digging in, or doing really hard things is exciting to you. And so then you have a culture and a place and a routine that supports you through the highs and lows of doing hard things. And I think it's just it's so important to make sure that whatever we can do to get rid of like a lot of risk without getting rid of that excitement, curiosity, and the incentives to explore good ideas, we just have to be doing. And I don't think it's easy in finance. I think we can understand people's ownership, at least of their capital or their compensation. or the prior compensation. But I think in science, it's a little bit more complicated to unbraid the threads. But I think that one big gift we have is this natural selection, that the people who have chosen to do this are all extremely smart, and the thing that they really want and that they've more or less carved out a huge amount of space and time to do is to figure out these problems, that the problems themselves make them tick, and then being around the other people. But you still need to have a palatable environment with a really strong culture that supports people while they do hard things.
I remember maybe 4 or 5 years ago, Chris and I were, we report out to your committee, council twice a year. And I remember a whole meeting around community, and it was really, initially it was really shocking to me. And I was like, well, we have a community. And, you all just kept hammering on, no, like, yeah, you have a community, but don't take it for granted. You got to work this, you have to continue to think about what the community needs, how to create the right culture. That's hard work. That doesn't just happen, Okay, you have a community, but like, do you really have a community? Do you really have the right culture? And one of the comments that just came in, which I think, your comments really resonated with this person, is to really think about, can you have a community where you can have really constructive criticism around ideas, and that's okay, right? That of course is going to lead to much better outcome, better ideas, great interactions. And so, that creating that has to be, ultimately critical in order to move things forward, to move ideas forward. So one of the other, I'm going to just flip to a question. We have 15 minutes left, which I can't even begin to believe, but this is a question about how do we as scientists, do we do a good or a bad job in terms of communicating our science to really engage, a broader community of people in what we're doing? And the comment is that there are many brilliant scientists that, that they may have exposure training, be good at doing their experimental work, but is there a way to think about how we might do a better job at explaining what we do? Something missing there in terms of kind of communicating the research, the thing of doing research to a broader audience. And they mentioned the Alan Alda centers, which I think have been really great. But like, do you see a place for that? Do you think that that's missing?
Personally, I think it is. Like, I can tell you, having spent 2 decades at Goldman managing engineers, the thing that I think most engineers just aren't good at is explaining complex ideas simply. And there's a lot to be said for distilling down ideas into into simple terms, understandable terms. And frankly, where it became, I managed a team at Goldman where this became very clear to me was when we finally hired our user experience engineers. These are the people that would take all the brilliant modeling we did and pricing work that we did and data that we did, and they made it look great, and they made it easy to use, and they made it all of that IP that we had spent tons of money developing was actually getting used simply because it was accessible. And so I think people tend to underestimate the value, and it's tough because the underlying statement is that form over substance maybe, but I think it's form and substance. That's the difference. And so I think it's absolutely critical that engineers and scientists who are doing especially things that are complicated spend the time to explain it not just to the people in the field, but people outside of the field. I think it's really important.
Just to add a small thing, Adam, and not to break the flow, but I also think scientists need to appreciate the reentrant value of explaining their ideas. In other words, you get good stuff back if you take the time to make it accessible, because then people who don't happen to be in your small niche come back at you with great thoughts about what you're doing, because it's form and substance. It should be just a continuum of that. And it has this wonderful reentrant value. It's like, oh, we have discovered this, and now we will let the people know. Or if you do that, then you're going to hear back, and finding ways to hear back at a lot of levels about what's important, in the science we're doing, but also about the ideas themselves. And not being so restricted in how we hear back is one of the values of it too.
I think it goes without saying that everybody who's this is why we're doing this, right? Is to communicate at least, and to find out what are the questions, and to be in dialogue that's a little broader than the four of us sitting in a room, which has been such like a pleasure, and to also have scientists with us. I do think when I look at this challenge, and of course it's, for me, maybe everything is in the light of COVID now, we did see this challenge as a society, but one of those stunning and important successes was what a great job scientists did for describing things for other scientists in their field. In particular, I do think that if we go look at the example of the very high end of immunology, like I think about like a Galit Alter at the Reagan, like of explaining in a way that's engaging, exciting, and accessible, and a layperson can kind of follow, that's really good. But the important thing was it was enough for another scientist to begin to think who wasn't in the field. And so that made it so that we could get more scientists chiming in. And maybe we needed this cover of a crisis for people to think they were going to engage and pay attention to things that were a little farther afield than their usual thing. But this is what we need to do right now as science, by necessity, becomes more and more specialized and narrow, that you now have a lab of 8 people who are extremely expert in what you're doing. And I think we need to bridge these conversations. Some of these conversations are really, really nice and they interlock. Some of these conversations, because people are talking very different languages, kind of interfere. And it's very hard for us to teach, like, if we had a graduate student, people who are, doing one kind of method, and we have a way of knowing, and we have one process in one discipline, whether it's like when we try to get immunology to talk to epidemiology, right? Like we have seen this need. So we would be crazy to walk right by. It's a fun problem to solve. It brings a lot of the stuff we want. It has huge rewards. I think it's low-hanging fruit, and it's a great question.
Yeah, I've always wondered whether it would make sense for grad students to have to do like some presentation training, as part of their coursework. Because I think it's so, like, if I think back to, growing up at Goldman, I wasn't a natural presenter or speaker. And so these were skills that I had to learn. And I think, purely out of, commercial interest, it made sense to do it. Whereas I think in academia, it's a little less obvious that is also an essential skill. And I think, it's something that, that we should seriously consider.
I think one of the things that's really exciting when you see the undergrads in the lab is it's obvious that being at a lab at Brown doing this, you understand that it would be exciting to use the rest of the place, which is doing nothing but giving these skills, so that you could explain to your friends who are interested in film what the fuss is about. And so I do think this is an exciting thing. And if, and Brown is very obviously, rich and wonderful community with all of its privileges around this kind of thing. But if kids can leave there being able to explain the science they're interested in, the science they've done, or the science they think needs doing, that is going to change things as much as anyone being able to express their point of view clearly.
And I really like the also like not to take for granted that just because you're a scientist, you know what another scientist is doing. And like ultimately, that's the bridge, you know, to collaboration. And I think we do take that for granted. And I think it's a really.
Chris, you could talk a little bit about that journey for how you were able to take these crazy ideas around, you know, genetic modification and light and mice and turn that into a tangible outcome that actually will help people who are suffering from, brain fluid disorders.
There's a lot there, but I think one thing that's really featured in that, I was actually thinking of the Chord Plexus brain fluid work as a great example, because there's this, you know, think of the name of our field, neuroscience, right? It's named after literally a cell type for, you know, this was meant to be pitched to someone who doesn't think about this. It's named after a neuron, which is a very specific kind of cell. We literally named the whole field after one kind of cell. That's going to create some bias in what we think is risky or not risky to work on. And so parts of the brain that couldn't be more important to health, like this one structure called the Chord Plexus that Adam and I have talked lots about. It's much more like, as we've discussed, a lung in the brain in terms of the cell types, but it sits in the middle of the brain and probably plays these amazing roles in things like memory and maybe even, if you're allowed to say it, consciousness, and certainly affect, maybe motor control. And yet it gets ignored because it's not of the cell type that the field is named after. So it's deemed too risky to be the focus of. So in that particular effort, you know, that we were doing that, you know, Adam made possible, we were trying to bring all the tools that were used for neurons and said, what if we could bring that kind of interrogation to a different spot in the brain? Maybe that's a risk area that's worth exploring. It's a mine you haven't dug in terms of trying to get insight, and inarguably important. Like, we know there's useful outcome there because of its link to disease. There's an inarguable link to disease, but people hadn't made the connection to like things like memory and consciousness and motor control and all the things that go with that disease.
Yeah. I mean, the more general, I think it's a really great example. And I think Chris has been a little humble here because it's his own work. I think there's so many examples that we could think about that would be amazing if that worked, but like, we don't know if it's going to work. And so that would be the broad answer to the question. But others would be, if you're combining two different fields, you know, in the way in which things are reviewed right now, it's really difficult to convince one group that what you're doing is going to be impactful and meaningful. And now you have to convince two different groups that you're that in two different disciplines that okay, your project is going to be meaningful and impactful. And then, you know, heaven forbid that you add a third discipline, and now you've got like three different groups. And so there's a inherent risk built into our system when you start to work at that interface of multiple disciplines, because ultimately you need people to come in and actually say, well, do I think this is going to work? Well, no one's ever done that before. But that's where you have to sit. And so like that's a really gnarly challenge in research, but it's exactly where you want to be. And so I think Chris's description of, you know, the chord plexus neurons, but that's where you need to sit in order to make advances in Chiari disease and all of these other related disorders. And so that's, I think, a really great example, and it's really a broad example in the end of where a lot of the risk stands in terms of, will you be able to do it? You've never done this before. And despite the fact of being scientists, people question whether you can technically do something, which at some point kind of makes sense, but doesn't make sense, because you can collaborate and, you know, bring in a lot of other areas. So I'm going to jump now to the last question, which I'm going to kick over to Nancy. We have very little time left. Again, it's like a time warp doing this, but there's one last question, which I think is very cool, and just kind of wrap things up. But, you know, I think it's a lot of what we were getting at. We're scientists, and we often don't think about how we bring kind of management skills, you know, thinking about like the structure of the system we're trying to work in, and how do you, are there parallels, or there advice that you can give and strategies about how to be think strategically, is the way that I would wrap it up, as a scientist running a lab, which is really a small business, actually. I mean, if you've got a group of people.
Every lab is a small business, and it
Right.
has the problems that every big and large business have, which is businesses that do well have people in them. And I think we need to explore how to make it easier for everybody to communicate and to manage people and to be managed. I think that it's a really trenchant question, comment. I think it is a challenge of this moment. I think there are real structural things to do right now that there have never been to do before, to take people who would like to manage other people and labs, and to teach them basic stuff that people learn who decide that all they can do is manage people and things and process. It is a non-small problem, but it's also had a lot of work done on it. And I think there's a lot of things that first principles, what works, are pretty basic, and we do not require that people sit and exhibit mastery of those basic concepts before we leave them in charge of other people in those careers. And that at some level needs to be on us as leadership, right? Like, we need to say, okay, you came here to graduate school. The person who you're working with has been required, just like they know like how a cell works, to understand what it means to get in and out of graduate school and to do things that are going to work in this field or adjacent fields. And that might have some increasing returns to us, that we could do more of standing on the bridge between fields, because these intersections are what's interesting, and what's interesting to us, and what's exciting in brain science as we think about different parts of how we know things, what we know about the brain, what's going on with the biology. And we have to knit all these things together. And so we have to, I think, ourselves learn to lead, ourselves learn to manage, and then bring people along on that journey and try to figure out how to make it a little bit more fun rather than the torturous part of everyone's life. It just ought to be a great and enriching thing. Like my relationship has been with you guys, like the absolute fun it is to brainstorm about your problems every summer. Like, this can be fun, right? This can be part of what we like. Curiosity, problem solving, and it is really fun to mentor people. And that, of course, is not going to mean that every day is a holiday or there's no problems. It's all part and parcel of the same thing. But we could be doing a lot more, and I do think it would behoove us to convince, if we don't have the resources to do it, to come up with them.
So one just quick thing I have to say is, I wish we had a tape recording of the conversation we also had, so we could make it a 2-hour block, because I feel like we didn't even touch on 90% of the fabulous stuff we talked about before we came in the conversation. But there was one thing I just want to make sure I had like 10 seconds of time, which is, you both made this great observation that the ultimate resource of any place is its junior people. And if we don't care and feed and help mentor and help through in whatever way we can, it's not like older folks know the best answers necessarily, but knowing how to do that wisely, and it matters so much they learn how to manage, to the extent that it can be taught. And it's probably not even taught by the older folks, but we should get outside people to help teach it. Maybe from Goldman, Adam. But that's a huge part of the stresses that come with management are intense and can be totally derailing in terms of progress, even if you're getting the science right, although they go together. It's just, it's such an important thing to emphasize. And it was such a neat parallel just to hear when you were saying that between your world and ours, that everything comes down to that. So I just wanted to sneak that in under the 4 minutes after wire.
Yeah, and there's no better pipeline than Brown, frankly, for that.
All right, that's going to be a quote. That'll be an outtake quote.
You won't find people on this call disagreeing about that comment. Like, so sadly, I'm going to wrap this up, but this was brilliant. And Chris, thanks for the closing remark, because yeah, we did chat a lot, and we have over the years about the critical importance of, you know, people just starting out, the scientists kind of at the early stage of their careers, and like that they're just absolutely essential, and that we should protect them at every level, to make sure that they can just, you know, really push the field forward. It's where a lot of the creativity and innovation is coming from. So I think that was really critically important to say. Thank you. So it leaves me to thank everybody for joining, and especially to thank Nancy and Adam. You got a snippet, a little snippet of the kinds of discussions that we have had ongoing for many years, and hope to continue to have them going into the future. And you've got a little sense of some of our secret sauce in Carney, and certainly Nancy and Adam being really wonderful colleagues, devoted, energetic, and just really digging in deep and learning about brain science, but also giving back hugely to us in terms of thinking our way through having impact. And that's really what we are here to do. So I'm just going to announce very quickly that on October the 12th at 4 p.m, Emily Oster, who's the Royce Family Professor of Teaching Excellence and Professor of Economics, and Amitai Shenov, who's an Assistant Professor of Cognitive and Linguistic and Psychological Sciences, will be discussing with us how uncertainty impacts decision making. And I also know that Adam and Nancy could join us and also talk on that topic. But we'll be having Emily, so I hope you'll both join us for that too. Thank you everyone for participating. This was tremendous. Bye.